Hello, welcome back to the channel. So let's do a different problem in this video, which is on calculating an indefinite integral specifically using partial fractions. So you might get these type of questions in your midterms or even in your final exams where you will have to calculate or evaluate an indefinite integral or a definite integral using a specific process of solving that integral. So you might get a question for evaluating an integral using trigonometric substitution, using substitution, or using partial fractions as well. So in this video, this question is about calculating this integral specifically using partial fractions in this case. So now if we want to solve this integral using partial fractions, we know that we want factored out terms in the denominator, right? So we'll have to manipulate this integral over here such that we have factored out terms in the denominator and a similar looking expression which could be solved using partial fractions. And in order to do that, we know that we'll have to do some kind of substitution in order to convert this integral such that we have factored out terms in the denominator. And if you'll perform that trial and error method where you're basically taking different choices for your u function, you will realize that it would be better for us to take our u function to be the whole expression, which is the square root of 1 plus e to the power x. You will clearly realize that if you take your u function to be this expression over here, you can use partial fractions in order to evaluate this integral over here. And we'll completely notice this approach in this video. So if we assume a u function to be square root 1 plus e to the power x, we know that the du would simply be 1 over 2 square root 1 plus e to the power x, which is basically the derivative of a square root function, and we'll have to use chain rule as well and calculate the derivative of 1 plus e to the power x, which would simply be e to the power x, and then you'll have a dx term as well. And now you know that in terms of dx, you'll have this expression over here. In terms of square root 1 plus e to the power x, you'll have u in this case. So now let's solve for our e to the power x in terms of u first. And if we do that, we can square both of these sides. So u square is equal to 1 plus e to the power x. And based on this expression over here, we can clearly write e to the power x as simply u square minus 1, right? So our du would be simply 1 over 2. This expression over here is u, 1 over 2u. So it would be 1 over 2u, and e to the power x is basically u square minus 1, and then dx would be as it is, right? So now we can use this formula and this formula over here in order to change our integral, manipulate our integral such that we can evaluate the new expression using partial fractions. So we know that we are basically calculating the integral of this expression over here, the integral of 1 plus e to the power x dx, and since we assumed this expression over here to be u, this would be simply calculating the integral of u, and if we want to calculate the value of dx, it would simply be, we'll shift this 2u to the other side, we'll shift this expression to the denominator, and if we do that, it would be simply 2u du upon u square minus 1, right? And then on the right hand side, we'll have a dx term. So if we use this expression over here, it would simply be 2u du upon u square minus 1, right? And now you can simplify this expression. This expression would simply be 2u square upon u square minus 1 du. And in this case, you see that you can clearly simplify your denominator over here. U square minus 1 can be written as u minus 1 times u plus 1 du. But now in this case, you realize another pattern over here, that the degree of the polynomial in the denominator is equal to the degree of the polynomial in the numerator, which is definitely not allowed if you want to use partial fractions, right? So again, using the same concepts that we discussed in the previous videos when we had these expressions over here, we can either use long division to simplify this integral such that we can have the degree of the polynomial in the numerator to be at most 1 less than the degree of the polynomial in the denominator. And you can do that, you can basically simplify this integral as, you can write this integral as simply 2 times u square minus 1, because we want a u square minus 1 term over here. So if we have 2 times u square minus 1, we will have to also add plus 2 upon u square minus 1 over here. And then we can have du expression over here. So now, if you'll solve for this expression over here, you know that 2 times u square minus 1 would be 2u square minus 2, and since you have the same denominator, so 2u square minus 2 plus 2 would be 2u square upon u square minus 1, which is this expression over here. And if you solve for this expression, you can clearly get this expression as simply 2 times u square minus 1 upon u square minus 1 plus 2 upon u square minus 1 and then du over here, right? And then this would be simply 2 plus 2 upon u minus 1 times u plus 1 and then du over here, right? Because you can easily convert this denominator into u minus 1 times u plus 1. And now this would be simply calculating the integral of integral 2 du plus integral 2 upon u minus 1 times u plus 1 du in this case, right? And now you can clearly use partial fractions to calculate this integral. You know the integral for this expression, which would be 2u in this case. And now you can clearly solve this expression using partial fractions only and without using any other approach for integral calculations, right? So now if you solve that, this would be basically 2u, and if you'll use partial fractions to calculate this integral, this would simply be calculating the integral of 1 upon u minus 1 minus 1 upon u plus 1 du in this case. So now you can solve for this integral expression over here, and at the end you will add the constant of integration when you'll get rid of the indefinite integral. But there is also one important thing that you have to keep in mind, that you will get your answer in terms of u. In order to get your final answer, you'll have to convert your expression, your answer in terms of u, to an expression in terms of x, right? Because you want your final answer to be in terms of x over here. So that's it for this video. Again, the main takeaway from this video is sometimes you'll have to evaluate some integral expressions using particular methods of integral calculations. And in order to do that, you'll use all the basic approaches that you know about solving those questions using those particular integral calculation methods. So that's it for this video. Again, feel free to comment down in this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye-bye. Take care.